What if I tell you that understanding the computer hardware inside your computer can unlock a whole lot of possibilities? How do these unseen parts work together to power your games, manage your data, and connect you to the internet? We are going to delve into the fascinating world of computer hardware. We will talk about the system unit and what is inside the system unit. Let's get rolling. In our previous lesson, we talked about the system unit, how it looks like, the front view and the back view, and all the ports that are behind the back view. Today we are going to look inside the system unit. What is inside the system unit? Most of the processing and storage devices show up inside the system unit. This session will look at the major elements that you find inside the system housing or the case. The picture over here shows inside the system unit or the chassis or the case. We have the power supply, the optical drive, the power cord, the processor which is beneath the fan, the hard drive, the motherboard, the memory slots, and the SATA data cables. These are some of the parts or the things that are inside the system unit. Take a very good look at it. Now when you look inside the system unit, we have the processor, which is also known as the central processing unit, and is the brain of every computer. The processor performs a limited set of calculations based on the request from the operating system and controls access to the memory. The processor speed is measured in several ways, including clockwise or megahertz, circle clockwise or megahertz, and gigahertz, and millions of instructions per second, MIPS. Any of these measurements gives you an estimated processor speed or its power. Now let's look at how the processor looks like. This is the inside of a processor. The inside of a processor. When you open a processor, this is what you see in it. Now, as I told you earlier, most of the storage devices of your computer can be found in the system unit. Storage devices on your computer, they are responsible for storing data such as the operating system, applications, and the actual output applications or data usage. Depending on the amount and the type of data, the 7 basic types of devices to work with are: we have the floppy disks, the hard drive, the solid state drives, the hybrids, the optical drive, the magnetic tape, and the flash drives. I'll show you a picture of it so that when you see them, you mention them by their names. This is a floppy drive and the disks, the drive and the disks, the hard disks, the solid state drives, the magnetic tapes, the optical drives, and the hybrid and the flash drive, which is also known as, sometimes we call it the pen drives. When we are dealing with the storage device, the 4 major technologies used to connect the hard drive to the computer motherboard are the IDE, which is the full name is the Integrated Drive Electronic, the ATA, Advanced Technology Attachment, and the PATA, the Parallel Advanced Technology Attachment. Then we go to the SATA, the small component system interface, and the SAS. These are the storage, the four major technologies used to connect to the hard drives to the motherboards. Know the names and know the abbreviation and what each of them stands for. So this is how the IDE looks like, and the SATA and the SAS. This is how they all look like, and the connectors, where you connect each one to. When we talk about the SATA, what is it at all? It is usually thought of as an internal technology, but there's rising in popularity of eSATA, that external SATA, which provide an external connector to the SATA bus. Some external USB drive have also support eSATA connectors. The type of drive that you can attach to your computer depends on the types that are supported by your motherboard and the input and output cards. So now let's get into the memory. The memory of a computer is a solid state, that is non-movable parts storage medium, and it can take many forms such as the RAMs, the flash RAMs, and the erasable programming RAMs, that's the EPRAMs. Access time for the RAM is measured in nanoseconds, that is 1 billionth of a second. When a memory is discussed, it usually refers to the RAM, which is the computer's primary storage memory. The RAM is the computer's primary storage memory. RAM is a form of storage, like RAM is we store things on it for temporary usage. Many people may not think of a RAM as a storage medium because it is volatile and it loses its information when power is removed. But temporary storage is still storage. RAM always provide a temporary, it's always temporary and it requires power to retain information. When you put on your computer into a hibernating stage, the content of the RAMs are written to a file, then retrieved when your computer is powered on. Now, the RAM is where you work with your computer data and programs. ROM, and the EPROM in your computer holds the operating code for your computer, which includes the power on self-test, the post routine, and motherboard level processor. We shouldn't confuse the ROM operating code with the operating system, which is stored on a hard drive and runs in the RAM. Still on the memory, this is a picture of how the memory looks like. It always resides on a memory module and are inserted into memory slots. The memory chips are usually reside on a memory module and are inserted into a memory slot. So the amount of RAM necessary in your computer often depends on the type of software you plan to use. So the amount of the RAM that you use depends on the software that you use. If it's a 2 gig or less, if it's 2 gig to 8 gig, and if it's 8 gig to upwards, that amount will depend on the types of software you are going to use. Okay, so let's do a recap of what we have learned so far. we are going to do a recap of what we have learned so far. Let's take the following question to do a recap. Take your pen and your paper and let's answer the following question. The first question states that state any four hardware components found inside the computer system. We just did that. And the speed of a processor is measured in several ways. Mention just two of them. And access time for RAM is measured in watts. We just did that. So I'll give you a few seconds to practice this as we prepare to move on to our next section. System board. The term system board describes any number of circuit board that makes up the internal of your computer, but it is used most often to describe the motherboard. The motherboard is the main board in your computer that contains the bio chip, the RAM, the input and output ports, and the CPU. This board contains the electrical part that enables all other components to communicate with each other. The motherboard is alternatively known as the main board, main circuit board, the system board, the base board, the planner board or logic board. Colloquially, we can say it is a mobile. Now let's look inside what are on the motherboard. So this is a pictorial of a motherboard or system board or a mobile. These are the things that when you take a motherboard, you can see on it. These are the things that you can see on a motherboard. The NOT bridge. This is how it looks like. The AGP slot, the South bridge, the PCI slots. Let's see the number of slots we have for the PCI. 1, 2, 3, 4, 5. Okay. Then we have the ChipMOS backup battery. This is how it looks like. And the connectors, all the connectors that you can see. The integral peripherals. Look at them. Look at the connectors. And I believe we know what each color means. These are the connectors that will connect you. Then we have the CPU circuit, the CPU fan. The fan is somewhere here, or the heat sink and the CPU fan and the heat sink mounting points. Then we have the 20-pin ATPS power connector. That one is also here. Then the DRAM memory slot is also here. An IDE connector that we talk about is also on the motherboard. So this is virtually what you can see on the motherboard. Here we leave you some time for you to look at each of them and where it is found. So next time you see this thing, you'll be able to identify what it is. What it is. Okay, let's move on. We are still in the system unit. The motherboard is the main circuit board of the system unit. This thing should be at your fingertips. The motherboard is the main circuit. So when we ask you the main circuit board of the system unit, the answer should be a motherboard. And the computer chip contain integral circuit, that's the ICs. This is how they all looks like. The CMOS battery, we talk about it in the first picture. Okay, let's move on. Now we move on to the daughter board. It's also in there. It's a secondary board that contains motherboard function such as disk or input and output control. It's a secondary board that contains it also contains a motherboard function. A daughter board is a board that contains some of the chips that could not have been put on the motherboards but were not. Let's take it again. It's a board that contains some of the chips that could have been put on the motherboard but they were not. Perhaps because of special limitations or other reasons. So some of the chips which were not able to be put on the motherboard are then put on the daughter board. Due to one or two reasons. If it's not able to be on the motherboard, we put it on the sister board. And it is common to see them used in laptops and other devices. So the sister daughter board is used in mostly in the laptops and other devices. This is how a sister board looks like. So this is a whole motherboard, and on the motherboard we have a daughter board that is over here. A daughter board that is over here. This is how the daughter board looks like. So let's move on. Then we move on to the power supply. The power supply does exactly what its name suggests. So power, so it means it's power the computer. It supplies power to the rest of the components in the computer. That's the main work of the power supply. The power supply takes 120 to 240 volts depending on the country in which you are. So it depends on the country that you are in and the volts that will be the power supply will give you. Alternating current, that's the AC from your electrical outlet and convert it to 3.3 volts, 5 volts and 12 volts or direct current. It contains a number of LEDs that supplies different voltage for different types of devices such as the hard drive, the PCIe expansion cards and the floppy disk, which will not likely have a need for. So the power supply is the work of the power supply. It converts all the walls outlets of the AC power into the DC power. When I say the AC power, I mean the alternative current from your electrical outlet and convert it to this of the, when you see DC is the direct current. Hardware have a lot of abbreviations, so we should try and put them in mind. The power supply converts all the AC outlets powered into the DC power, outlet power into the DC power. Some external peripherals have AC adapter, which is an internal power supply. Now let's talk about the adapter cards. Adapter cards allow you to adapt your computer to another role, such as controlling assembly line robots, or to add specific function to your computer, such as the printing. The most common adapters are now integrated into the motherboard. So most of the adapters are now into the motherboards. These components include the display, the network, the keyboard controller, the mouse controller, the serial ports, the fire output and USB ports. So all these ports are integrated into most of the motherboards. Adapter cards, when the first computer came out on the market, most of the elements, if not all of them, were added to the motherboard by using adapter slots such as the ISA, the PCI Express, and the AGP. No, so these are some of the adapter cards that you see: the AGP, the PCI Express, and the ASI, and the PCI. These are all adapter cards. Now we move on to the expansion slot and the adapter cards. We have to know what an expansion slot is. An expansion slot is a socket on the motherboard that can hold an adapter card. So the work of the expansion slot is to hold the an adapter card. An adapter card enhances functions of a component of the system unit or provides connection to the peripherals. It provides connection to the. So this is a picture of how it works. It looks like. With the plug and the play, the computer automatically can configure adapter cords and other peripherals as you install them. Expansion slot and the adapter cards. Types of the adapter cards and the purpose is clearly stated over here. So the cable card allow the viewing of digital cable television channels. That's what the cable card allow. The disc and the fireware and all those things. The PCI connects to the PC to TV connector. It connects TV to television. Connect the TV and the television. Connect them. And the USB connects you to the USB devices. So these are the adapter cards and its purpose. The adapter cards and each of them their purpose. The fireware connects to the fireware devices. The ADTV tuner allow viewing of ADTV broadcasts on the monitor. MID also connects musical instruments. Now let's go to the cooling system and the fan. The cooling system and the fan is used to remove heat. So to remove the heat from a computer system, there has been a steady increase in the use of fans, vents, and other heat dispensation units. Heat sinks with fans are commonly placed on the processor and critical chipsets. Heat sinks are made of heat conductive metals, that is usually aluminum or copper, with the solid state in contact with the chip that are practicing and the thin fans on the other side, thus putting greater surface area with the air, which helps dissipate or transfer heat to the air. So that's what the cooling system and the fan does to the computer. It mainly works to remove heat from the computer to the air. So that's how the cooling system look at the fan, and this is how it looks like. When you see this, you should be able to know that this is the cooling system of the computer. When you use a fan with a heatsink, it allows more cool air to flow through the fans. Case vents and fans also bring cool air into the computer housing and also vents and pull out hot air. Fast processor produce more heat. So as the processor have become faster, more method for pulling the heat away from the processor have also been developed, such as the liquid cooling system. So the processor, as time goes on, the processor is becoming hotter and hotter. So there have been another way. That's the cooling system. Liquid cooling system. When we say the liquid cooling system, what is it? The liquid cooling system is the reduction of heat and temperature of inner environment through exploiting the properties of liquid. It is the reduction of heat and temperature of the inner environment through exploiting the properties of liquid. Liquid cooled machine maintain desired operating temperatures of the environment. Before we move on to the advantages of a liquid cooling system, I want us to go over what we have done so far. So we started with the system board, we defined it and what it is. Then we went on to another name for the motherboard, that's the main board and the rest. Then we went on to look at how the system board looked like inside the system board and the components or the chips that are in it. Then we went on to look at the motherboard, how it also looks like and how the integrated circuit is. Then we went on to the daughter board, which is when some of the chips are not able to be put on the motherboard, they are then put on the system daughter board. So we look at the pictures, we look at the power supply, what it does, and the volts, how each country and the volt that is being supplied to the country, and how the power supply looks like. Then we came to the adapters and how they function. We then move on to the adapter cards, how each of them looks like, and the expansion slot and adapter cards, how they are. Then how we went on to look at the expansion slot and the adapters and the purpose for which each of them is being used for. Then now on the cooling system, what the cooling system, then a picture of the fan. Then now we are on the liquid cooling system. So we will continue with the advantages of the liquid cooling system. A liquid cooling system is an efficient system for mitigating heat away from the processor and outside of the system unit. It allows for higher speed in the processor. So one of the advantages is that it allows for a higher speed in the processor. The cooler the processor, the higher speed it gets. Another advantage of the cooling system is the reduction of noise in the computer. Most of the combination of heat sink and fans generate a lot of noise because the fans usually have to circulate. Large volume of air over the processor at a high speed and through the system. Liquid cooling system requires much less space and also gives good performance as well. So these are the advantages of the liquid cooling system, some of them. The firmware and the chipsets. Firmware falls in a middle ground between the software and the hardware. So the firmware is between the software and the hardware, where the distinct line begins to disappear. The firmware is program code software that contained in stored on the IC chips on your hardware computer. The combination of the firmware and software makes up the BIOS on several different devices, with settings stored in the chip modes or the flash RAM. The compatibility of these chips and the code that ties them together is provided by a single supplier, and this group of chips is referred to as the chipsets. So this is a picture of the firmware and the chipset, how it looks like. Everything we are doing, we talk about it and we give a visual representation of what we talk about, so that the lesson will not just be in an abstract form. So you have a view of how what we are talking about looks like. Now let's go to the BIOS. When we say BIOS, a short form for the basic and output system. The BIOS is actually a software that is stored on a ROM on the motherboard. Most systems today use a flash EEPROM to store BIOS so that the user can update the program code in the BIOS. The first program on a set of instructions that runs when a computer is switched on is called the BIOS. So when I ask you of the BIOS, you should be able to tell me what the BIOS is. That is the first set of instructions that run when the computer is switched on. The BIOS is responsible for coolly controlling and managing low level that's extremely important process like the post, that the boot process and the interaction of components on the motherboard. That's the responsibility of the BIOS. So this is how the BIOS look like. This is how the BIOS looks like. We now look at the UEFI. When you say UEFI, what does it stand for? That is a Unified Extensible Firmware Interface, and it represents the next generation of low-level ROM-based code that controls the motherboard processes, but with a great deal of enhancement. UEFI is capable of supporting advanced diagnostic tools even without having an OS installed on it. The advanced diagnostic tools, the UEFI is capable of supporting it. It also supports network booting, secured boots, and even has a limited shelf for running commands. So now we are going to compare the UEFI versus the old BIOS and the new BIOS. That's the old BIOS and the new BIOS. Now we are going to compare the BIOS versus the UEFI. Does the BIOS have a blue screen that resembles BSOD, and the UEFI is user-friendly graphically. It has a nice interface when you use it. And another comparison between them is that the BIOS cannot recognize large storage devices, but the UEFI can. And the BIOS can only be used on the keyboard, but the UEFI is used in mouse. It's able to be used mouse. It is able to use mouse in the interface. Now I move on to the CMOS. Sorry. The CMOS, that is a contemporary metal oxide semiconductor, which is often confused with the BIOS and the UEFI. BIOS and UEFI is programmed code that is stored on the RAM, and the EEPROM ROMs, and controls the loading of the operating system as well as the low-level functions. BIOS often have a setting that the user may control, and these settings are stored in the chipmon. So the settings are stored in the CMOS memory. While CMOS refers to the type of manufacturing process that creates the integrated circuit and most other circuits. So this is a pictorial of the CMOS, how it looks like. How the CMOS looks like. You see how it looks like. Okay, I'll leave this one for now. How we'll check the outside of the system today. That's not our main topic now. We will not check outside the system unit. We are only dealt with the inside the system unit. So we will end our lesson here and do some exercises. We will learn our lesson here and do some exercises. Thank you very much. Let's take the following questions and answer them. Number one is mention any three major technologies used to connect hard drives to the motherboard. To the main circuit board of the system unit is known as what? 3. Which hardware component inside the system unit converts the wall's outlet AC power into DC power? And what is an expansion slot? Then you write the acronyms for the following. That the CMOS, the BIOS, the UEFI, and the EPROM. So answer the following questions and we will meet again for another hardware topic. Thank you very much.